Welcome back, everybody. And we're on to the next session of talks. The first one by my colleague from Brazil, Ulisses on the BRICS telescope network prospects for Brazilian contributions to the observation and study of transients. Ulisses, please go ahead.
Thank you very much, David. I'm going to share my screen now. Hopefully it work. Okay. Do you see that? Full screen now?
Yep.
Okay, very good. So I'm going to follow up on the discussions of this morning, and in particular on the general briefing that was given by David and Braz on the Intelligent Telescope and Data Network, and develop a bit the perspectives for Brazilian contributions and scientific exploitation of this network. Of course, this is a partial account of what Brazil could and probably will do on this, but is what I could gather from the community of participants in this project, and for the people that have been attending these meetings, these past meetings, particularly the one in Brazil, where we launched this idea of the flagship network. And so these are the main authors that have contributed to this presentation, but there is, as you can see here, a large list of people, of which I'm really the porta-voce, in the sense that I'm just referring to results of consultations from them. And I include here two people to which I give an additional thanks for contributions, which are not in the list of co-investigators of the project, strictly speaking, but are leading radio astronomers in the country who can and wish to contribute from the side of radio facilities. So let's go to the instrumentation and infrastructure. As you know, it has been presented and discussed several times by Bruno in these meetings. The National Laboratory of Astrophysics is the main institution that runs the observatory facilities in Brazil. And there is a number of instruments with which Brazil can contribute to the BRICS network right from the start of this first phase, where the idea is to put instrumentation already in place, already existing together in an intelligent way to do combined observations. So there is the Pico dos Dias Observatory, which is the main inland Brazil instrument in Brazilian territory. Brazil has also access to Gemini, SOAR, and is on the process of discussion renewal of access to the CFHT. And of course, there is on LNA as well, the Roscosmos Panels space debris telescopes, which fits very well with some of the aims for the transient searches. For example, such as presented by Boris Shustov. And that there are also a number of other restricted telescopes, which really means purpose-built telescopes, which can also join the network and contribute. So very quickly on the Pico dos Dias Observatory, it's constituted of a number of medium and small instruments, varying from 1.6 meters to small robotic 40 centimeter telescope. But they have a capability, very wide capability in the optical and infrared, from photometry, polarimetry, spectrographs. And so it's a very flexible set of instruments that can very well and very nicely join the network. And there is also in the same site the Roscosmos Panels, which is a survey telescope for space debris, of which the full data bank is available for use by the Brazilian community, and through that by the BRICS Corporation, I suppose. I would like to highlight also a new instrumentation that is being built for the 1.6 meter telescope at the Pico dos Dias Observatory. That's the Spark 4 camera. It's a simultaneous polarimeter and wrapped camera in the SDSS 4 bands, G, R, I, and Z. And the very good characteristic, apart from this multi-band, is the very, very fast time resolution of sub-seconds of the camera. This means that this is a very nice instrument to produce time series and therefore to the study and follow-up of transients, both in photometry, differential photometry, and polarimetry together. So here is some outline of the status of this Spark 4 So at the moment, it's been, the instruments are being constructed and tested at the laboratory for on-site, in situ test in the telescope next year. And so hopefully by 2022, the instrument will be operational and delivered for science in the telescopes. Very quickly, the Brazilian participation on these large facilities in Hawaii and Chile. And these are very large instruments, first-class instruments, globally speaking. And Brazil has some observing time in all of them. In particular, in SOAR, Brazil has a very significant amount of time, and this is quite convenient for the network, as the 4-meter size of the telescope allows for very deep observations and follow-ups of faint sources. And a little bit about the other more restricted telescopes. There is the Impacton, which is a national observatory led instrument in the Brazil Northeast, which is a region where really there is a lack of instrumentation if you consider the latitude. And so it's very interesting, and it's focused on searching and monitoring of solar system small bodies, which again fits well with part of the transient objectives. And there is the T8, is an 8 centimeter filter photometry instrument at Cerro Tololo, which is run by the University of São Paulo, and it also fits very well the goals of this network. And of course, we have a radio telescope since a long time in Brazil. It was part of network of the LBI in the past. It has been doing important studies in masers and variability of AGMs in the 22 and 43 gigahertz bands since the 1970s. It's a 13.7 radome enclosed antenna, and it's just been re-inaugurated, so it's in place for integration with the network from the radio side. So that's a very nice complement, and this is controlled and operated by INPE and the University Mackenzie at São Paulo. A little bit about computing resources. Of course, it was already mentioned by our colleague from China, the important role of the virtual observatory. Brazil has a virtual observatory groups called Bravo, and I think today it sits mainly on the University of São Paulo. But we have a facility for HPC computing, the National Laboratory for Scientific Computing, which is an institute of the Ministry of Science and Technology. And they have a data extreme lab, which can give great contributions to this project as well. Basically, providing big data algorithms and implementation of those, and also HPC computing facilities for BRICS data network. It's important to mention that this institution also hosts the largest supercomputer in Latin America, the Santos Dumont supercomputer. And so this is a very important resource that we can use for the data processing and data related activities of the BRICS network. Some key scientific interests of the community. Of course, this is a very narrow focus. I mean, as you could see, we already talked about the monitoring of asteroids and minor solar system bodies. But another aspect that is the community involved in this project is very keen on is the study of classical nova, and in particular, the understanding of a recently population of fast and faint nova that has been discovered in external galaxies. For example, here, some of these objects are cited in M31, M81, M82, and so on. Interesting questions that have been raised about these sources is why haven't we found yet such sources in the Milky Way? And if there is any reason to believe that these fast and faint nova are physically different from the fast and bright, more normal ones. And if so, how is so? And for these objects to be studied, it's really important to have a good set of instruments capable of reaching good sensitivity and capable of doing monitoring within the weak time scale, which is perfect within the goals of the network. Another aspect that was highlighted was the search for pre-maximum of the galactic nova. So to study the emission in the rise part of the light curve of the sources. And this requires very fast and very good quality optical TO alerts, which is from what we have seen from the cadence aimed by the network, it's an excellent and perhaps unique niche for the BRICS telescope network. So for this field of nova, it's readily clear that the network opens a vast amount of research possibilities, and it has readily drawn the interest of the Brazilian community that's working on this topic. I should also mention that continue on these high cadence capabilities, there is another aspect, of course, for the studying of these novas with high cadence of observations, basically daily observations, to search for the rapidly oscillations in the longer evolving trends of the light curves of these sources. And for doing this, it's of course very, very important, the ability of continuously monitoring this source via ground-based observatories scattered around the world. And this is the case for the BRICS network as well. Before finishing this part, I would like to include AGNs, which is my personal interest as well, but it's an interest of, for example, the community involved in radio astronomy in Brazil, a very strong interest. And of course, we all know that AGNs have a very complex variability behavior, from very long time scales to extremely short time scales. We know in gamma rays, which is my field, that this can go down to a few minutes only, where you see variations of 1 or even 2 orders of magnitude in the brightness of the sources. So these are exceptional objects for which the close monitoring in multi-band spectrum is very important. And here, I think, is a perfectly placed place where the radio capabilities that have been mentioned in this meeting and the optical capabilities of the BRICS Intelligent Telescope Network can really fit to give unique results and therefore cooperate together. Regarding this radio cooperation, it was already mentioned by David in his talk, but there is this Yama radio telescope, which is, we can say, is a long arm of ALMA. It's an ALMA antenna displaced towards a southern location in Argentina at 4,800 meters altitude. And it's a long arm for extending the capabilities of ALMA observations. And this is being already constructed, the antenna is ready, but the site is under development. And so hopefully very soon, the telescope is going to be operational. And it's a Brazilian-Argentinian initiative. So Brazil will have full access to this instrumentation. And so the first light of this observatory is expected in a couple of years as well, or less than that. And here I highlighted among the wide science case that is proposed, the capability not only of doing VLBI images, but also of studying quasar variability. And to finish my presentation, I would like to mention this new initiative for VLBI Ibero-American Network. It's a joint effort by a number of Latin American countries, of which Brazil, Costa Rica, Colombia, Ecuador, Peru, Argentina, Uruguay, and Mexico, plus Spain and Portugal, to establish a VLBI network among these countries. The idea is to make this doable in terms of cost by using existing telecommunication antennas that are usually large and defuncted because they're not being used anymore by the companies that originally created them and built them. And so this can be refurbished and can be put to work as an integrated network. There is a first attempt to do that is being discussed nearby here in Rio, 50 kilometers north from the city. It's the Tangua antenna. It's a Star One company antenna. And researchers, particularly from the University of São Paulo, are following very closely the discussions to retrofit this antenna for astronomical purposes, in particular for VLBI. And the idea is that the single dish observations could start as soon as in 2 years. And if this project goes to fruition and is ready to work in the network as proposed, then it would be indeed a very fine addition. And I can mention also the parallels between this and the VLBI Africa network that is also being constructed. So I leave you here my summary, not to take more time than necessary, but the idea is that there is a large interest from the Brazilian community to work on the network for various science topics. But more than that, we have numerous facilities that could contribute from day one to the network via this integration, intelligent integration of the BRICS infrastructures to start doing observations together in optical and radio in a coordinated way. So thank you very much.
Thanks very much, Ulysses. We got time for a quick question if there are any. I had one about Brazilian participation in the Rubin Observatory LSST. If you could say what that is, if there is indeed plans, and whether or not you had been considering using your optical facilities for any LSST related follow-up.
Yes, I am aware of some interest in participation or some effective participation, but I'm not the best person to answer. I think there is people directly involved in the network which are in this meeting now, so I would give them the chance to comment. Is there anyone that could do that?
Hi, Dave. Luis here. Yes, I'll be talking about that 2 talks from now. Okay.
Okay, that's excellent. Thanks.
Very good.
Okay, then thanks very much again, Ulysses, and we'll move on to the next presentation from Jifeng Yu, the National Astronomy Observatories of the Chinese Academy of Sciences, and he'll be speaking about the efforts towards the mega project Citian, which you heard me mention at the beginning.